Hey guys, it's me again. I'm going to show you how to graph a secant function now. So for a secant function, like I showed you guys today in class, it is necessary for you to know how to graph a cosine function. All right. So in reality, this is more of a review on graphing cosine than it is on graphing secant. Okay. First of all, I want you guys to see the relationship here between my secant graph, which is solid, and my cosine graph, which is dotted. All right. You notice that they coincide at the peaks. All right. That also they're separated by asymptotes. All right. We're going to talk about each one of those pieces right now. Okay. So we're going to start by saying, all right, if I can graph, if I'm going to graph secant, I need to graph cosine. So I'm going to start just with 2 cosine of x, which I believe everybody can graph. All right. That's just a regular cosine function with a period of 2 pi, right? Going from, so one cycle between 0 and 2 pi, right? I've got my window between negative 4 pi and positive 4 pi, so you can see more of it. Okay, but that's one cycle between 0 and 2 pi. It's a regular cosine function. I went ahead and changed the amplitude, so that means I go up to 2 and down to negative 2. No big deal. All right, next thing I'm going to do is I'm going to change the frequency. All right, changing this frequency, I will now have half. Okay, so if you notice my frequency right here, I am now going to have only half of a frequency between 0 and 2 pi. So I'm going to change that, and here I go, same amplitude, but you notice now I've only got half, okay? So between 0 and 2 pi, I've actually only completed half of a cycle, all right? So that means that a full cycle won't be complete until 4 pi. Let's pause real quick. Quantitatively speaking, this means, remember my formula for period is T equals 2 pi, because it's sinusoidal, 2 pi over b. All right. So if my b value is 1/2, I'm essentially doing 2 pi divided by 1/2. 2 divided by 1/2 is equal to 4. All right. So my answer is 4 pi. That's the length of one period now. 4 pi. I got one period every 4 pi units. Okay. Going to continue. The next transformation is rather simple. It is the negative transformation. So the only thing that's going to do is it's going to flip my function. All right. Every peak is now a minimum. Every minimum is now a maximum. My zeros remain the same. I still got one period between 0 and 4 pi. Okay. Remember, the period for cosine starts at a peak, ends at a peak. Okay. Last thing I'm going to do is I'm going to change my midline. My midline will no longer be 0. It will now be 1. So up goes my cosine function. All right. Just so you can tell that everything moved, I'm also going to graph my midline. So this is something that I recommend when you're doing this. I recommend that you graph your midline. So there's my midline at y equals 1. All right. It's important to keep track of that. So in your drawing for cosecant, this is what I would have. I would have this transformed cosine function. I'll graph the midline. Some of you guys might go as far as to also graph the 2 peaks. That's okay. You can graph the boundaries. All right. If you don't want to, no need. I'm gonna take them off. And the next thing is we should know now where our asymptotes are going to be. Our asymptotes are going to be where the original zeros of cosine were. So at negative 3 pi, negative pi, positive pi, and 3 pi. All right, because wherever cosine, the original cosine function equals 0, that's where secant is undefined. All right, because that would be dividing by 0. So there's negative pi, there's positive pi. Notice how it lines up very nicely with the intersection of cosine and the midline. There's negative 3 pi, and here is positive 3 pi. So all of this work I've done prior, let me get myself out of the way here. All right. I've done all this work prior to actually graphing cosecant, or secant, I mean. All right, now, if you remember what secant looks like, I will have parabolas that touch these peaks and are in between these asymptotes, okay? Oh, here I go again. And that'll be the last thing that I do. I'm gonna go ahead and draw my secant function, and there I am. All right, you notice it fit nicely right there, all right, with a minimum at negative 2 pi, comma 3. Here a maximum at 0, negative 1. Here a maximum at 2 pi, comma 3. If you're wondering how I'm going to grade you when you take this assessment, one of the quick things that I do to check if you're right or wrong is I ask you to label at least 2 or 3 points, right? If you've got these points labeled, I don't even have to look at your asymptotes. I don't even have to look at anything else. I know that you got it right. All right. But all this comes from all the prior work that you did. Notice, again, everything that I graphed prior to secant is dotted because it's not really part of the graph. It's just kind of the backbone that allows me to see what the actual graph looks like. All right. That is all. That is all I have for you. Have a good afternoon.